Hello there, my name is Ben and welcome to this math video tutorial on statements and truth tables. So those are two topics that we're going to talk about in this video, and we want to begin our discussion with statements. And so what is a statement? A statement is any sentence that can be true or false. So if we go on our notepad here, let's look at some examples of our statements. So, an example of one statement could be, President Obama was elected in the year 2008. So, that's a statement. It can be true or false, which is true. Another statement you may have is like with mathematics. You could say, if x equals 3, then x plus 2 equals 5. So that's something that can be shown to be true. Another example could be, all crows are black. So, that could also be true or false. I'm kind of thinking it might be false statement. I don't think all crows are black. I guess if we run it, I don't know too much about crows, but if we want to change it to something like all dogs are black, then we definitely know that's a false statement, because there are white dogs, brown dogs, and there's like spotted dogs, like Dalmatians. So yeah, those are some examples of statements. Anything that can be true or false. Now, examples that are not statements can be something like, you are wearing a pretty cool shirt. So basically an opinion, someone looks at your shirt, he says it's pretty cool. You can't really say that's true or false. You could say another example that would not be a statement is, let's go to the zoo. So there's another sentence, that can't be true or false. And then, you may have a question is why do we need to learn this? So that's also not really a statement, so that's a question. Let's see. Another example that would not be a statement is if you're using math, you could say, just saying the inequality, x is greater than 10. So this is not really a statement, because we don't really know what the value of x is. We would know if it was true or false based on a given value of x, so that can't be a statement. If we were to modify it here in the statements, we said x is greater than 10, given that x equals 11, then we know that that's true, because 11 is greater than 10. So that is definitely a statement. But if we just know that x is greater than 10, but we don't know the value of x, then that can't be a statement. So those are just some examples of telling the difference between statements and ones that aren't statements. So with that in mind, we're going to go back to our statements and truth tables here on the blackboard. And usually when you're dealing with logic, it's just kind of a branch in mathematics. You usually use like variables, or letters to represent statements. So, so let's say, you wanted to have, P can be a statement, and then Q could be another statement. And there's also these symbols that you learn too with logical connectives or logical things, like there is the AND statement, and the symbol that you use for the AND statement is this caret symbol. So it's like doing the shift and the number 6 on your keyboard. And then the OR statement is just like the opposite, but it's kind of turn this upside down to make it a V. So it's like the letter V. And then we also have the NOT. And the NOT, you can use, two different symbols depending on if, some logicians use one symbol that's like a tilde for NOT. And perhaps if you're taking a math, computer science-based class, you may use this symbol for the NOT as well. Kind of like a right angle is kind of inverted. So you can use one of those symbols, the tilde or this symbol right here, kind of a upside down L. So those are the basic logical operations. There are some other ones we may get into in this tutorial, but at this time what we're going to do is go through some examples, just how to write this symbolically, and then we'll go into doing truth tables and how to determine truth values. So let's say we had P be the statement, and we'll put a colon next to it. John goes to the store. And then we'll say Q. It'd be a statement. John works today. And let's say if we wanted to say, John goes to the store, and let's say and John works today, if we want us to do both, then we can represent that symbolically as P and Q. So we use this caret symbol and Q to say that John goes to the store and John works today. So we'll write that down over here. Statement 1, John goes to the store and John works today. So another way we can express this is we could do, like, instead of saying John goes to the store and John works today, we could say, John goes to the store and works today. So we can combine those together, not having to write the the name John twice in the statement. And so let's see, statement 2. What if we said that John does not work today? So how do we express that symbolically? Oops. Clicking on the wrong thing there. That's my Netflix. So the way to express that, if we say John does not work today, we know Q means John works today, so we can express that as not Q, tilde Q, or the other, the inverted L. So that symbol and Q. So that's how we can express that statement. Okay. And then also we could do another statement, statement 3. Let's see. You know, we could say either John works, you know, today, or, you know, he goes to the store. So either John works today or he goes to the store. So we know Q is John works today, P is John goes to the store. So if it's either and or, then we're going to use the or symbol, which is V. So we can say Q or with the V, P. Represent it that way symbolically, Q or P. Okay, so there's also another symbol we could talk about, and it has to do with the if and then. So if you say if, and then you have a statement, say P, and then something happens as a result, then Q. So the way to represent that symbolically is you're going to write F to P, and then an arrow sign, right arrow, sign, and then Q. And then, of course, if you wanted to reverse the roles, if you wanted to say, you know, if Q, then P, then you would put Q first, and then the arrow, right arrow, then P. So we'll get into this as far as the truth tables go, you know, with the if statement, if then statements, and all of that good stuff. But I just wanted to show you how to write that symbolically. Let's see here. So we could think of one more statement we could write symbolically using these two, and maybe we just want to add like another statement. We could say a random statement. We'll just call it R, since R comes after Q, and we can say that, you know, Sally you know, goes on a date with John. So that'd be our last statement there. Sally goes on a date with John. So let R be that statement. And so we could say, how can we represent this symbolically? Let's do one more statement here. Statement 4. So if we say something like, if John, goes to work today, then he either goes to the store, or Sally will go on a date with him. So this statement's a little more complex, but we can break it down to its parts. So we start with the if part, so we know if, and then we know John goes to work today, so whatever comes after the if, we know John goes to work today. So we look at that, and we see that John goes to work today, that's Q. Okay, so we'll put Q here. And then we look at what comes after that, the then. So then he either goes to the store. So goes to the store, that's going to be P. Or Sally will go on a date with him. So we have or Sally goes on a date with him. So we know or is the V symbol. And then Sally will go on a date with John, which him is John, so that's or R. So that's how you would do that one. Q, and then right arrow, P, V, and R. Okay, so there we did a few examples of how to write statements symbolically, using the letters and using their symbols for the and, or, not, and then the if-then statements. So what we're going to do now is we're going to go over truth tables, how to construct those using our statements symbolically. And feel free to rewind or pause the video during this tutorial if you need to review or need a chance to write something down, taking notes. And that's what's great about these videos, is you can do that. Okay, so we're going to do truth tables. So what we're going to do is we're going to look at a basic truth table just using one statement, which is P. So you're going to have a couple columns. One column is for P, and then we'll use not P. We'll use the tilde this time. I may use the other symbol later on. And what you do is for P, since we have one statement, we know it's either true or false. So we'll put T for true, F for false. And the not P just means you're going to take the opposite truth value of what you have. So the opposite truth value of T, true, is false, so that's F. The opposite truth value of false, F, is true, that's T. And so there we go, we have our truth table for P and not P. And then you always circle your final result, which you have is F and T in this column. So this is the not. Now let's say we had two statements. You have P and Q. So this time, so we have P and Q put together. We have two statements. We're going to have, first thing we had in our first table is two possibilities. This time with two statements, we're going to have four possibilities, so it actually doubles. So we'll have T, T, F, F, two trues, two falses. And then for the Q column, you're going to do T, F, T, and F. Alternating in truth value. So T, T, F, F, T, F, T, F. And what we're going to do is we're going to evaluate the P and Q. So this will be our AND. Yep, AND right there. So the way to evaluate the AND for two statements, P and Q, is you need to look at the truth values of each statement. If both of them are true, then the result's going to be true. So like P and Q, we have both true. So T and T makes T for true. And if P and Q are different values, true and false, that has to be false. False and true, F and T has to be false, F. And then if they're both false, F and F, then that also has to be false. So the only time P and Q for the AND statement can be true is if both statements P and Q have to be true. Otherwise, they're false. So there's a result for the AND. Now let's take a look at the OR statement, P or Q. So here's OR. And so with OR, there's a little more flexibility with truth, because with OR, T, true and true, they're both true. And as long as one of the statements is true. Otherwise, if they're both true, it's true. But if both are false, then it's going to be false. So true and false will make true. False and true will still make true. But if you have both of them are false, then this is false. So we have T, T, F, F for the OR. So you can see here for AND, we had one true, three falses. And then for OR, we had three trues and one false. So it's totally the opposite. So when we think of OR, we're thinking inclusive. It's just like if a server at a restaurant asks you if you want soup or salad, it may imply that you want both and not just one or the other. So you could say, soup or salad. You could say, I want soup and salad, or you could say, I want either salad, not soup, or soup or not salad. So you could have both. Now there's another statement we could use where this was called the exclusive or the XOR, and that's where you have one or the other but not both, and we'll actually go over that here in truth table. So let's see, so we did the AND, we did the OR. We could go over the if P then Q, so that's P with the arrow and Q. So with this one, the way to find out the result's true, you need to look at what P is doing. So if P is true, then it has to be true for Q to also be true. So if true, then true is true. If P is true, and then it says then Q is false, then we know, we would see that that'd be false. And then if P is false and Q is true, that's going to give us true. And then if P is false and Q is false, that's also going to give us true. So the only time that if P then Q is false is when P is true and Q is false. Otherwise, it is true. So another one we can look at is what's called the converse, where you switch the P and the Q. So the Q will come in front, the condition, and then P will be like the result. So if Q, then P. So this is called the converse. So we just call that conditional. This is like converse. So just reversing. And then, so if we do that, we're going to look at Q, because that's first, then P. So we know true and true, that's true. False and true, that's true. True, Q is true, P, false. We know that's false, right? Because the one in front, if that's true, the condition is true and the result's false, we know it's false. And then if both of them are false, that's going to give us true. So you can see that the converse is not exactly the same as the conditional statement. P, if P then Q is here. So that doesn't follow. So you can see there's two different results. Okay, so let's see here. We could look at some other ones, or we could do something a little more complex. So let's say we did P here, we have Q here. We're going to do or not. P, we'll use the other symbol this time. Or not in Q. We're going to do not P or Q. And then what we'll do is we're going to compare that to not P and not Q. Now let's see what kind of result we get here. And so we start with our P's like we did in this first column. We did T and T, F, F. Then we had T, F, T, F. And then with not P, we take the opposite truth values that we have. So this is T, that's F. T, then F. And then these last two will be T's. So they're F's. So just taking the opposite truth value. And then the same for Q. So we'll take the opposite of those. So that's going to be F. And then we had T, F, and T. And then we're going to do not P or Q. So we need to look at P or Q first, do that in parentheses, and then take the opposite truth value. So we're going to do T and T, T or T, that's T, but the opposite of T is F. Not T is F. T and F, that's T, but the opposite is F, not. F and T is T, and not T is F. F and F is F, F or F is F, and then not F is T. So we have that one there. So F, 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 T. And then we also have not P and not Q. So we say we're comparing these two columns here. So F and F, that's F. F and T is still F. T and F is still F. And T is T. So what can we say about these two columns here, these two statements? We can say that not P or Q is, we'll say logically, that's equivalent to not P or not Q. And something to try as an exercise is just to see if not P and Q, is that logically equivalent to not P or not Q? So you can see if that is going to be true. And when you do that, you should find out that it is a true equivalence. So another thing you would try to do is try to do this conditional statement, not Q implies not P. And we could do that really quickly. Just looking at Q and P, we just have the nots. So we could look in this table here, not Q, not P. So F and F, that's T. T and F is F. F and T is T, and T is T. So look at that result. And we'd see that T, F, T, 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 F, T, T. So we can say for sure that if P then Q, that's logically equivalent to not Q plus not P. And this statement right here is called contrapositive. It's called a contrapositive. So if you wanted to use if P then Q, instead of just using that form, you could use not Q, if not Q, then not P. And that still give you the exact same form. So we could say, we could use a quick example here, just like a statement. If if x squared equals 4, then x, or let's do this instead. If x equals 2, then x squared equals 4. So that would be original statement, but if you use the contrapositive, you can do this around. So you can negate the x squared does not equal 4. So you would say if x squared does not equal 4, then x, you would negate this part, does not equal 2. So that would be example using a contrapositive, is flipping the p statement, which is x equals 2, and the q statement, x squared equals 4, and then negating each of those. So the negation of x squared equals 4 is x squared does not equal 4, and the negation of x equals 2 is x does not equal 2. So that's how that would work. Okay, so that is basically, in a nutshell, how truth tables work. I guess one last thing that I wanted to go over with you is, there's another way you could do this with the truth table. There's another form you could use. So let's look at that really fast here. So with P and Q, you could use, let's see, maybe we want to add a third statement, say R. And now that we have 3 statements instead of 4 possibilities, we have 4 times 2, 8 possibilities. So just doubling each time. So instead of using the T's and F's, you can use a 1 for T and a 0 for F. So 1 equals true, 0 equals false. So you could have, we'll have our 4 T's, or 4 1's, and 4 zeros. And then for Q, we would do 2 1's, 2 zeros, 2 1's, 2 zeros. And then for R, we would do 1 0, 1 0, 1 0, 1 0. So just right into the side here, 1 equals true, 0 equals false. And then we can evaluate some statements here. We could do, let's say, P and R. And then we could do Q, and let's say or P and R. So something a little more complex. And then let's see what we get. So if we look at the P and the R, we know that in order to be true, we have to have both 1's. So 1 and 1 is 1. 1 0 is 0. 1 and 1's 1. 1 and 0 is 0. 0 and 1 is 0. 0 and 0 is 0. 0 1 0, and both zeros are 0. So there we go for P and R. And then to do Q or P and R, so we just look at our P and R, evaluate that first, and then we do or Q. So 1 or 1 is 1, 0 or 1. 0 or 1 is still 1. 1, 0 is 1. 0 or 0 is 0. 0 or 1 is 1. Let's see, 0 and 1 is still 1. 0, 0, 0. And 0 is 0. So we get that result. And there's something that was called the exclusive or the XOR. We can go over that. And you use this symbol like a plus with a circle around it. And we'll go over what that means. So if we wanted to evaluate P, the exclusive OR with Q, that just means you have one or the other but not both. So that means that the only way to have true is if they both have opposite truth values. If they have the same truth values, P and Q, then it's going to be false. So if we have 1 and 1, that's 0, because they're the same. 1 and 1 still 0. 1 and 0, they're different, so that's 1. 1 and 0 is 1. 0 and 1 is 1. 0 and 1 is 1. 0 and 0 is 0. And then the same thing, 0 and 0 is 0. So we get that result. So that's how the exclusive OR works. Only true if P and Q have opposite truth values. If one's true, the other one's false. And it's false if they're both true or both false. So it's kind of like that soup and salad thing we talked about earlier. It can only have one or the other, but this time I can't have both. I can either have the soup or the salad, but I can't have both of those as an appetizer. And probably one more thing I wanted to mention. I guess I thought this was the last thing, but one more thing we should. It's always one more thing, right? If you watch that show Columbo on TV with Peter Falk. But I promise you, this is the last thing, and it's about two different important terms. They're basically total opposites of each other. One's called a tautology. And then another one's called contradiction. So the tautology is, a statement where it's always going to be true. So, it's going to be true all the time. All the time. And then for a contradiction, it's going to be false all the time. So, you can probably think of an example, like of a tautology. Maybe, we could try one here. Let's see, well, let's see if you had P and you had not P. So if we did, that's T and that's F. And then you had, that's F and that's T. And, if you wanted to say P or not P, so T or F is still T, and F or T is still T. So P or not P is actually a tautology, because it's true for all cases. we got both T's. So notice that we went back from the T's and the F's. We were on the 1s and 0s, but I thought maybe you got tired of seeing 1s and 0s, the binary stuff, so thought we'd go back to a more higher level language with English, with T's and F's. So that's an example of a tautology. Now let's look at an example of a contradiction. If we had P, let's say, and not P. So we know P and not P, so T and F, that's going to be F for false. And then false and true, F and T, that's still going to be false. So that's a contradiction where it's false for all the time, for all cases. So there it is, tautology right here. And then right here we have our contradiction. Okay, so this has been, for the math video tutorial. We talked a lot of stuff here today about statements and truth tables. Feel free to rewind or pause the video again if you need to rewatch this or take some notes. I know it's a lot of stuff, but hopefully you were able to get the gist of it, and do look forward to doing more videos, so stay tuned, and hope you have a good day. Take care. Bye-bye.